You see, yesterday we just discussed about what are fundamental quantities and what are derived quantities. We also tried to define some of the fundamental quantities. So, just once, can you name the fundamental quantities?
So,
Yeah, can you name the fundamental quantities?
length, time, current,
Hmm.
temper
Length, time, current, and
temperature, current,
hmm,
luminous, luminosity,
okay. So these were the units which we studied. You can see here. We have studied for length, mass, time, temperature, amount of substance, electric current, luminous intensity. Okay, so these were the seven fundamental quantities which we studied. So apart from this, there are some supplementary quantities which are provided. Those are for measuring the plane angle and solid angle. So we'll discuss them also. They are of quite importance. See, also I would like to bring your attention, all of your attentions to this point that if you observe the symbols of the SI unit, okay, if you observe the symbols of the SI unit, some of them you find in capital letters and some of them in small letters. So there are only two units which are written in capital letters. You can see Kelvin and Ampere. They are the units which have been written in capital letters. All others are written in small letters. Okay. So for time, second is written as small s. For length, meter is written as small m. Mass is written in kg. Small everything. Only these two, Kelvin and Ampere, they are written in capital letters. So these points need to be taken care while writing the units. Then I will be discussing about the plane angle and solid angle. So here, angle measurements. Okay. So what are the different angle measurements? Okay. So up to now we have studied the measurement of the angle. How do we measure the angle? Yes. What is the way? How do we measure the angle? What are the units for measuring this angle?
in degrees,
Degrees. We measure the angle in degrees. So this is a sextant method which we use. That there
Hello. Hmm.
okay. So see, we were here. We were discussing the measurement of angle in. So 1 degree is equivalent to 60 minutes. So that means 1 degree can be divided further into 60 parts, and each part we will call as 1 minute. And each minute would be equivalent to 60 degrees. So this measurement we call as the sextant measurement. Currently, we do not use degrees. Instead of degree, we use radian measurement of the angle. So we say radian measurement. So let us see how we define the radian measurement and how different units can be measured over here. Different angles can be measured in terms of radian. So radian measurement in radian measurement, we find out the angle as the ratio of length of arc to the radius. So suppose you have this. Suppose let this be the radius, and you have the center over here O. Your center is O, and now so suppose I'm making this angle. Now see how what will be the value of this angle in radian measurement. If this is the radius, so the part AB, I'll call this part AB, the circumference part AB, the part of the circumference which is AB. This we call as the length of arc. So this is your length of arc denoted by the symbol L. So the angle in radian or radian measurement of the angle is given by theta is equal to length of arc divided by radius. Okay. So if length of arc is equal to the radius, so your angle will be equal to 1 radian. That angle we will call as 1 radian if the length of arc is equal to the radius. Okay. So in this way, there are if you observe, length is also measured in meter, radian is also radius is also measured in meter. So overall, it does not have any dimensions, but its SI unit is in meter. SI unit will be radian. So this is the radian measurement of it. Now let us try to find out their equivalents in case of degrees. So suppose you have length of arc by radius. So we know that for a 360-degree, it will be making a complete circle. Okay, so I can say for complete circle. So for complete circle, we know that angle in degree would be equal to 360 degree. Okay, and let us see what that angle will be equal to in radian. So for complete angle, what should be the length of arc? If the radius is r, so the length of arc should be equal to the circumference, which is 2 pi r. Am I correct here? That if you take this complete one round, so the length of arc would become 2 pi r, which is the circumference of the circle, right? And if you divide this by the radius r, so you will get the value 2 pi. Now this value 2 pi, this is your 2 pi radian. So that means one complete angle in radian is equal to 2 pi radians. Right. So if you measure the angle in radian, the complete angle would be equal to 2 pi radian. And what this angle is equivalent in degrees? 360 degrees?
360.
Yeah. So we can say that we can say something like this, that 360 degree would be equal to 2 pi radian. Okay. So I can also say that 1 degree would be equal to, this is radian. So 1 degree would be equal to 2 pi over 360 radian. This is also equal to pi over 180 radian. Now you can easily convert. Suppose I want to find out 30 degree. So what would be the measure of 30 degree in radian then? See, 1 degree is equal to pi over 180. So what would 30 degree be equal to?
30 into pi by 180.
Yeah, it would be pi over 180 multiply 30. Okay. And clearly, if you cut it, you will see pi over 6. You get a pi by 6 radian. So mostly we will be saying pi by 6 radian. Instead of talking 30 degree, we will say pi by 6 radian. Right? If you say 60 degrees, so 60 degree would be equal to how much? Quickly perform the calculations in your paper.
Pi by 3.
Yeah, it would be pi by 3. I'm not getting answer from other people. Pritam,
5/3.
yeah, everyone is supposed to calculate and quickly answer. Okay, Pritam, Vedika, everyone. So what if angle is 45 degree?
45.
Yeah,
Pi by 4.
do it
1.
on paper, everyone. It's pi by 4. Okay, it will be pi by 180 multiply 45, you'll get pi by 4. Similarly, you get 90 degree, and that 90 degree would be equal to pi by 2. Similarly, you get 180 degree. So 180 degree would be equal to pi radian.
45.
Okay. So got all the radian measurements of the angle.
Hmm.
Okay. So here I can list out all of them. If you have 30 degree, so 30 degree in radian is equivalent to pi by 6. 45 degree in radian is equal to pi by 4. 60 degree is equal to pi by 3. And 90 degree is equal to pi by 2. And 180 degree is equal to
5.
pi. So similarly, you can change any of them. You should basically know how can we convert from degrees to radian. As see, most of the time now we will be using radian instead of degrees. So slowly we have to shift from degree measurement to the radian measurement. So in this way, we will be measuring our plane angle. So this angle, whatever we were measuring, this angle was the plane angle, right? So in the same way, we can measure a solid angle also. So what we mean by a solid angle? So let's try to see or try to visualize a solid angle. Okay, can anyone imagine a solid angle? And why do we need a solid angle? See, everything, all the things around us, they are in terms of solids. Okay, so
Hmm.
all the things around us, they are solid angles. They are not the plane angles. So we need to study the solid angle also. For example, if you take up a cone, okay, so if you draw a cone something like this, so here you are drawing a cone. So when I draw a cone in two dimension, I observe a 2D. I observe over here a two-dimensional angle, but in reality, this is a three-dimensional. If in reality you have a cone, so you will observe that it is a three-dimensional angle. Okay. So the same way as we had defined here, as we had defined for the plane angle, that it is given by the length of arc divided by radius. So length of arc divided by radius would be equal to angle measurement in degrees. So in the same way, solid angle measurement is also defined. Let this be the solid angle. So this solid angle theta, also called as T radian. So this is measured, solid angle will be measured in T radian. Okay. So how do we find out T radian angles? So a T radian angle or theta would be equal to area of the circumference. Area of this curved surface. So it is area divided by r squared. So this area divided by the radius squared is given as angle in steradians. Okay. So got the angle measurements. Okay. So let us say after this, what all other things we have. Now in the CGS system of units, CGS system of units means centigram, meter, second. So CGS, centimeter, gram, and second. So those units are called as the CGS units. Sometimes we may need to convert from CGS unit to SI unit, and sometimes we need to convert from SI unit to the CGS. Okay. So let us see how do we perform the calculations. To convert from one unit to the other unit, we use the formula N1 U1 is equal to N2 U2. Now, what these different things mean? N1 means the number of times of first physical quantity or first unit. Number of times of first unit, and N2 is the number of times of second unit. Whereas U1 and U2, they are the units themselves. So U1 is the unit in one of the system of measurements. U2 is the
So,
unit in the second system of measurements.
so N2 is N2.
Yes,
So, what is N2?
see, N2 is number of units or
Okay.
number of times. See what it simply means. If you observe measurement of a length, okay, suppose I want to measure this length. So to measure this length, either I can use meter or I can use centimeter. Okay. So if I'm using a meter, so let us say it comes out to be 2 meter. It comes to be 2 times of a meter. Okay. So if I write 2 meter, 2 meter means 2 times of a meter. When I write 2 meter, so 2 meter, it means 2 times of meter. Similarly, if I say 3 kilogram, so it means 3 times of
10
kilogram.
kilogram.
Yes.
Yeah.
Yes, Pritam, were you asking anything?
No.
Okay. So 2 meter means 2 times of meter. 2 kilogram means 2 times of kilogram. In the similar way, you can suppose instead of this meter, I'm using foot. So I will be saying it is something. It is equal to 6.2 foot or 6.2 feet. Now I'm saying. So this is 6.2 times of 1 feet. So both the quantities, they are measuring the same units. They are measuring the same physical quantity. So you should have 6.2 times of feet should be equal to 2 times of meter. This is what it actually means when you are writing N1 U1 is equal to N2 U2. So N1 means the number of times the first unit occurs, N2 means the number of times the second unit occurs. Okay, where U1 and U2 are the units. So let us try to convert this with one of the examples, and let's see if you are able to convert this. So here you are given a question. You can observe how many dyne centimeter are equal to 1 Newton. So you have to find out that how many dyne centimeter are equal to 1 meter. This is the question. Okay, so how many of you can convert? Can you convert dyne centimeter to Newton meter?
No.
Okay, see, use this formula N1 U1 equals to N2 U2. Okay, take here N1 to be, let this be Newton meter, U1 be Newton meter, and let U2 be dyne centimeter. Okay, so N1, instead of N1, I will write here 1. Since we have been asked for 1 Newton meter, so here I will write 1 multiply U1. U1 is the unit Newton meter. Should be equal to, I want to find out how many. So I want to find out N2, and my U2 is dyne centimeter. So here it is dyne centimeter. Okay. So I want to find out N2. Once I will be find N2, so I will know that how many dyne centimeter are there. So it will be 1 Newton meter divided by 1 dyne centimeter will be equal to N2. Now I want both of these to cancel each other so that finally your answer will be just a number. So either you convert this Newton to dyne and meter to centimeter, or dyne to Newton and centimeter to meter. Both ways you will get the correct. So as we know that 1 Newton is equal to 10 to the power 5 dyne. So I can write here 10 to the power 5 dyne multiply 1 meter is equal to 10 to the power 2 centimeter, and you have here on the denominator 1 dyne centimeter. So dyne centimeter gets cancelled, and you have the value of N2 as 10 to the power 7. So I will say that in 1 Newton meter, there are 10 to the power 7 dyne centimeter. Agree everyone?
Yes, sir.
Okay. So similarly, I will give you just one more question. If you are able to do that, just look up at that if you can do that. Okay. So here is another question. See, calculate the value of one erg in SI system. So what is one erg?
Yeah, what
Okay.
is it?
See, do you know what is the unit erg represent?
No, sir.
No.
So
Erg is the, yes,
energy.
energy, right? So erg we use for energy in CGS system. This is the formula for energy in CGS system. And we want to convert this to SI system of units. I want to convert to SI system. So I will write the formula N1 U1 equals N2 U2. Okay. So N1 U1 I will be taking this R. N2 U2 I want to take the SI system. Okay. So N1 at the place of N1 I will write 1. U1 should be equal to the R equal to N2, which I want to find out, and U2 will be Joule. Since for the SI system, energy is measured in Joule,
Joule.
right? Okay. So now let us see, if I find out the value of N2, then I will get my answer. Okay. Now for that, I want to expand this erg and Joule. See, to expand this, we know the formula of work done. Work done is given by force multiplied displacement, right? And this is the unit Joule. Isn't it equal to Joule?
Yes, sir.
Okay. So if force will be measured in Newton, distance will be measured in meter. So this will be equal to Joule. If force will be measured in dyne and distance in centimeter, then what would be the unit? Ergs. The unit would be equal to ergs, right? So here, now I want to convert. So I will write this erg as dyne centimeter. So 1 multiply dyne centimeter, okay, equal to N2 multiply Joule can be written as Newton meter. Now, how many of you can perform and tell me the answer? I am giving you 3 minutes. Okay, within 3 minutes, try to find out. Within 3 minutes, find out. You have already done a similar thing. So 1 multiply dyne centimeter Yes.
So 1 by 10 power 7.
1 by 10 to the power 7. Is everyone getting the same thing? 1 by 10 to the power 7. So can I write that 1 by 10 to the power 7 as 10 to the power minus 7?
Yes, sir.
Yeah. So I can write here 10 to the power minus 7 to be equal to N2. So I have got my answer that 1 UG will be equal to 10 to the power minus 7 joule. Got
Yes,
it?
sir. Yes, sir.
Yes, sir.
Okay. So in homework, I'll be giving you similar questions. There will be just 1, 2 questions similarly so that you can find them, convert them in the other units. Okay. For example, I would like you to find out uh, universal gravitational constant in CGS units. What will be the value of universal gravitational constant in CGS units? Can you do that?
Hmm?
Try doing this. This is a part of your homework. So as a part of homework, I am providing you. You have to find the value of universal gravitational constant in CGS units. So you have to find the value of universal gravitational constant, that is capital G. So in SI units, we know the value.
What is it?
In SI units, we know the value of capital G, that is 6.7 multiplied 10 to the power minus 11.
So can I repeat it again?
See, here it's written on the screen. You can see you have the value of universal gravitational constant G. Okay, so
Hmm.
universal gravitational constant capital G is equal to 6.7 multiplied 10 to the power minus 11 Newton meter square kilogram minus 2. Now I want you to find out this value in other unit, in CGS system of units. If we use the CGS system of units, so what this value will be equivalent to. The same thing you have to use. You have to use the same method. N1 U1 equals to N2 U2. The same thing will go. There is only one change. And first of all, you find out for 1. Find out for 1 Newton meter square kilogram minus 2, and then multiply by this number, you'll get the answer. Okay, so I provided you help also with this homework. Do this. So this is a part of homework. Okay, now let us see how do we perform different measure. Our next part is making the measurement. So how do we go about in making the measurements? How can we make the measurement? Okay, so first of all, a very common method is the direct method. If you are given to find out any length, you go on to measure it directly. So that method we call as the direct method of measurement. Okay. So do you think the direct method of measurement is applicable everywhere? Can we use direct method everywhere?
No.
No. So can you tell me the situations where we cannot use and where we can use? Yes, where can we use the direct measurement? Okay. Suppose you are supposed to you are told to measure the length of a table. So you will be using the direct method of measurement. Yes. Suppose you are told to find out the height of a building. So you can use over there direct method of measurement also. Now, what are the indirect methods of measurement? they are used for measuring very larger distances or very small distance. Okay, so direct methods are limited. If you use direct methods of measurement using a meter, scale, or any other, so they are limited. You have limited means. You have limited objects for which you can apply the direct methods. You have indirect methods which can be used to measure other units or other quantities which are very far off. For example, using the indirect method, you can measure the distance of Earth and Moon, which you cannot measure directly. You can measure the diameter of Earth. You can measure the diameter of Moon. Okay. You can measure the period of rotation of Earth. You can measure the size of particle. You can measure the size of molecule, okay, size of nucleus. So, do you think that to measure the size of nucleus, we use direct methods? No.
Yes, ma'am.
Okay. So, I hope you have understood about the indirect methods where we can use the indirect. We can use indirect methods for the measurement of length. We can use indirect methods for the measurement of very big distances and very small distances. So indirect methods, they are used for larger distances, for example, sun and moon, uh, width of solar system, size of sun, width of solar system, size of sun. Okay, so these are some of the larger measurements which can be made. Distance between two stars. So for that we need to use this we have to have some other methods of measurement. We also need for very small measurements. So suppose we want to measure very small measurement. So we cannot use a direct method. For example, suppose I want to find out the thickness of hair, the diameter of hair. I want to find out the thickness of a wire. So those are a very small measurements. So there also, for example, thickness of hair, size of molecule, size of molecule, size of a bacteria. So they cannot be measured up directly. They require some indirect approaches of measurement. Okay. So let us see how we can measure out, how we can find out the different distances. So see how can we measure the distance of moon, or how can we find out the diameter of moon. Okay. So let us see how can we measure the diameter of moon. This is one of the example. It is also called as the parallax method. So to measure the diameter of moon, so as we know that we cannot measure the diameter of moon directly, we need to use some indirect methods. And for that, we use electromagnetic waves, or we can use laser beams or EM waves to find out the distance between sun and moon and earth to find out the diameter. Okay. So since we have 3-4 minutes left for the class, so is there anyone having any doubt in today's class?
No.
Is everyone able to convert from one system of units to the other system of units? So see here, the measurement of length can be made using direct method of measurement, using measuring instruments, and indirect methods or mathematical methods or chemical methods are also there. So chemical methods are there for measurement of very small distances like the molecular distances. Okay. So they can be measured with the chemical methods. Mostly here in this syllabus, we will be studying about direct and indirect method. So in the direct methods of measurement, up to now we have seen is our normal scale. Even in the direct methods of measurement, we have seen our ruler scale. Apart from the ruler scale, you have other instruments like you have the vernier caliper, which is used to measure smaller distances. You will have vernier calipers.
చేసి
You will have a screw gauge.
ఇది వద్దు నా పాలు వద్దు
Yes, yes, Pritham. So while studying further, we will deal with vernier calipers and screw gauges. We will see how the different measurements can be made with the screw gauge and the vernier calipers. So just today, I'll just show you how a vernier calipers look like and how a screw gauge look like. So they have a vernier calipers and a screw gauge. They have a very high approximation. For example, vernier calipers can measure about 0.1 mm. A screw gauge can measure about 0.01 meter, 0.01 millimeter. Okay, so they have a very high accuracy. We can use these instruments even to measure the thickness of a blade, the thickness of a paper can be measured using a screw gauge. Okay, so just I will show you the figures or the diagrams of screw gauge and vernier calipers. So just I will show you the screw gauge. You see, a screw gauge. Okay, see, this is an instrument called as screw gauge. You have a circular scale and a main scale on this. So you can see here markings. So we'll see how to use them, how to find out their least counts. Apart from them, you also have the vernier calipers. So let's see vernier caliper also. A similar instrument here, vernier calipers, which you will be using in your school laboratory. So this instrument is called as vernier calipers. It will be used to measure the diameter of a substance. Okay, whereas screw gauge will be generally utilized to find out or to measure the thickness of a given material. Okay, so we'll see this in our later classes, coming up classes. For today, you should do the homework given. Okay, and you will be having a test also if possible. I'll upload a test also for whatever we have studied up to. Okay, so bye everyone. Good night. Anyone having any doubt?
Yes, I have a doubt.
Yeah.
So in the formula N1U1 is equal to N2U2,
Hmm.
can we like put anything for N1 or N1U1 and U2? Or it's necessary to keep U1 as the CGS and U2 as the SI unit?
No, you can keep any one of them.
Okay.
You can keep any one of them and it will be correct.
Okay. Thank you,
Okay.
sir.
Goodbye. Good evening, Vedika.
Good evening, sir.
Good evening, Datri. Datri, good evening. Okay, so Datri, are you not able to use your mic? Okay, so first of all, welcome all of you. Welcome both of you to the physics class. In the physics class today, we'll be doing about units and dimensions, right? So we'll see what are units and dimensions, what are units and measurements, what are the different measurements, why we need to measure in physics. First of all, starting with what is physics, what are the different things that we are going to study. So Vedika, can you tell what we are going to study in physics?
Units and dimensions.
Units and dimensions, very good. But see, there is a lot of gap between your grade 10 and grade 11 physics. In grade 10, you just need to have the formula, apply it, and you will be able to get that. You have to be clear with your concepts. Whatever concepts are there, whatever points are there, you have to get through those concepts, and then you will be able to get it. It's not tough. Like you can forget about the calculation part. The calculation parts are a very little bit, but the understanding part is too much. You have to understand each and every point to be clear. Okay. So may I request all of you to turn on your cameras? Your cameras, if your cameras are on, it's easy to see what you people are doing. Okay, during the class, if anyone is having any doubt, if anyone is not being able to speak up, so please intimate it. You can use the chat section here. If you are facing any problem, you can message through the group. Okay. So basically what we study in physics, that we study about the nature and natural phenomena. So that is what we study in physics, nature and natural phenomena. So can you think what are the things that we need to study when we are studying the nature? Yes, we study here nature and natural phenomena. So in the natural phenomena, what are the different things we study and how can we study all the things? Please turn on your cameras. All of you turn on your cameras. I hope the screen is visible to everyone.
Yes, sir.
Okay. See, the very first chapter in your physics is units and measurements. So here we are going to study how we are going to measure the things and why we need to measure the things. So what are the things that we measure? Is everything measurable? Can we measure anything? Come on, everyone, be responsive in your classes. Can we measure anything?
Like not everything.
Okay, can I measure your feelings?
No.
No. Can I measure your intelligence?
No.
No. So obviously there are many things which we cannot measure and there are a number of things which we can measure. So first of all, we define the physical quantities. What the physical quantities, these are the quantities, or you can say the quantities which are measurable. You can say the measurable quantities are called physical quantities. So we'll see what are the measurable quantities and what are measurable quantities are called physical quantities. So can you give me the names of any measurable quantity?
Distance.
Hmm?
The distance.
Distance and distance and
Speed, mass.
speed, mass. Very good. So see, these are the physical quantities which generally describe an object, its position, its properties, the position, properties, various things of an object, they are described. Suppose you are given this rod. So what are the things that you can measure for it?
Length.
Okay, we can measure its length, fine, and
Mass.
Width.
we can measure its mass. Any other thing?
It's volume.
Volume. Very good. Anything? Any other thing?
Area of cross section.
Area of cross section. Very good. Any other quantity? Any other thing that we
Its
can measure
density.
for this rod? Yes,
Its density.
we can measure its density. Very good. Okay, so these are the different things that we can measure about this rod, and all these quantities, they give us some idea about this rod. For example, the length give us an idea that how long it is, the mass give us that what will be the content of matter in it, volumes gives us an idea that how much space will it occupy. So in the similar way, all these are the physical quantities. These are the different things which we can measure about this rod, and all these are the physical quantities, right? So you can also understand what that physical quantities are, the quantities which are used to describe some objects, not only objects, maybe their properties. To describe the properties, we use some quantities which are called as physical quantities, right? So there are certain quantities which are used to describe. For example, I can say that someone is very beautiful, but there is no measurement of that. Okay, so that beautiful is not a physical quantity, it is just a quantity. Understood?
Teacher.
Okay, so in physics, we study about the physical quantities, and these physical quantities, they give us an idea that how the physical quantities, they give us about the depth of that unit. What are the things that we can think of? What its different properties we can study out of. Now, we have a number of physical quantities. Like you described here, length, mass, volume, area of cross-section, density. We have a number of physical quantities. Now, out of all these physical quantities, our SI system of units. So, SI system of units has introduced 7 fundamental quantities. Okay. The 7 fundamental quantities of the SI system. So, can anyone name the 7 fundamental quantities?
Length,
Length and
mass,
mass.
volume,
No, not volume. Volume is not a fundamental quantity. So what are fundamental physical quantities first of all?
Charge.
Charge. No. See, fundamental physical quantities are the quantities which do not require any other quantity for their description. They do not require any other quantity for their description. For example, length, mass, time, temperature. So length, mass, time, temperature, amount of substance, luminous current, and luminous intensity. So see, these are the 7 fundamental quantities as described by SI system of units. Now, these are the quantities that we cannot express them in terms of any other quantity. We cannot measure length, we cannot express length in terms of any other physical quantity. However, if you want volume, so we can express volume in some other terms. We can express volume in terms of length. We can express density in terms of mass and volume, right? But these are the quantities which cannot be expressed in any other terms of it. So therefore, these quantities, they require some standards. They require their definitions. Okay. So, how do you think should we define the length? What should be the unit of length? Since you want to measure the length, so you will be using an appropriate unit for measurement of the length. What are the different units that we use for the measurement of length?
teacher.
Yes, different units that are used for the measurement of length. See, we have different units. For example, length can be measured in meter. It's measured in centimeter. It's also measured in foot. Okay. Some of the local people, they may also use hand span. So these are the different ways or different methods of measuring the fundamental quantities. Okay. So Dhatri mic not working, Vedika camera computer. Okay. And Jaswant, what about you? What about your mic and camera?
So yes, sir, working.
Okay, so please turn it on. Jaswant, Pritam, keep your mic and camera on. So length will be measured in SI. Length can be measured in meter. It can be measured in centimeter. It can be measured in foot. So all these meter, centimeter, foot, they are units. They are the units of measurement. Okay. Now, out of these units of measurement, the SI system gives us meter. SI system defines meter to be the SI unit of meter, SI unit of length. So whenever whenever we have to measure length, length will always be measured in meter. The SI system also defines mass to be kilogram. In the SI system, mass will be measured in kilogram. Apart from kilogram, there are other units. There are units gram. Other units are also there, pound. But in SI system of units, we use kilogram. Can anyone guess the SI unit of time?
Second.
SI unit of time?
Seconds.
Seconds. SI unit of time is second. What is the SI unit of temperature?
Kelvin.
Yes.
Kelvin. The SI unit of temperature is Kelvin. What is the SI unit of amount of substance?
Mole.
Mole. Very good. And SI unit of current is ampere. The SI unit of luminous intensity is candela. Okay. Now, see, to measure the length, we use meter as the SI system of units. So, of course, we should also define that what should be 1 meter. Yes, what should be 1 meter? To what distance shall we call as the 1 meter?
100 centimeters.
How much?
100 centimeters.
100 centimeter. But how we will define then 1 centimeter? Yes, how we will define 1 centimeter then? See, of course, we need to know. Our problem is that we want to set up, we want to know that how much distance should we call as 1 meter. So, shall I take this much as 1 meter, this much as 1 meter? So, what should be the distance that I should call as 1 meter?
So it's a fixed standard, like for everything it's only one.
It's a standard. So, how do we choose that standard? Of course, you are very close. So, how do we choose that standard? How can we say that yes, this will be 1 meter? How can we make that standard? See, the way we define 1 meter is defined in terms of scientific community. It is defined in terms of the speed of light. So the distance, what distance we will call as 1 meter? The distance 1 meter would be, it would be the distance traveled by light. Since the speed of light is a constant, so the distance traveled by light in 1 over eighth, this much of a second. So the quantity which you see in the denominator, 299,458,798, this is the speed of light. So the distance traveled by light in this much of a second we will call this distance to be 1 meter in vacuum. So see, earlier the distance was defined in various other terms. For example, the distance was defined using a meter scale. You can define this distance in terms of meter scale. Suppose it can be that all the scientists agree to take a meter scale and then say that, okay, this will be 1 meter, right? But that was not defined as to be 1 meter. It was found inappropriate. For example, if you choose a meter scale to be of 1 meter and declare it to be 1 meter. So can you guess what are the problems that we can face? What are the problems that we can face? Yes, will there be any problem if I just use a meter scale and the scientific community says that yes, this 1 meter is accepted as 1 meter? Yes, will there be any problem?
Yeah,
Okay, what problem will be there?
it won't be appropriate.
Yeah,
It won't be appropriate.
it won't be appropriate. Why it won't be appropriate?
The value.
Why we cannot accept a meter stick to be of 1 meter? Any reasons? Just want any reasons? Okay, have you heard that metals expand on heating?
Yeah,
Solids expand on heating and contract on cooling, right? So, if you take a meter scale, suppose if you choose a meter scale, so you use that meter scale in Antarctica, you use that meter scale in a Sahara desert. So, will there be any differences in the measurement of the length?
yeah.
Yeah, because
Solids
in the
expand.
deserts, yeah,
Solids expand.
yeah, it will expand. So, it will not give you an accurate measure, right? So we cannot declare that meter stick to be a standard. The meter stick cannot be declared as a standard because it is not fixed. It will keep on changing. Okay. So the distance traveled by light in this much of a second in vacuum. So the speed of light is constant in vacuum, and in this much of second, whatever distance the light travels, to that distance we will call as 1 meter. Right? So this is the distance traveled by light uh, in you can say 1 over 3 into 10 to the power 8 of a second, right? So this much distance will be 1 meter. So in the similar way, the SI system, it defines the other units also, like the distance, the amount mass is measured in kilogram, and this in the same way SI system defines 1 kilogram. So how can you say 1 kilogram? 1 kilogram, it is defined as a prototype of mass. So a prototype has been made of platinum and iridium. So a platinum and iridium prototype has been kept, which we call as a 1 kilogram. So there is a platinum and iridium prototype kept in International Bureau of Sciences, France, that we call as 1 kilogram. Right? So how we define 1 kilogram? 1 kilogram is the mass of a prototype kept at International Bureau at Paris, France. So It is made up of, this is made up of platinum and iridium. So since platinum and iridium over there, the mass decay is considered to be very less. It's non-reactant. So therefore the alloy, it is made up of an alloy of platinum and iridium. It is kept at a constant temperature and pressure. So everything of that room is maintained at
What
which
is
we
alloy
keep.
name?
Yeah.
What is alloy?
Yes, you are audible, Pritham.
Like what is alloy name?
What is?
Alloy name which you mentioned.
Platinum and iridium. It's made up of platinum and iridium.
Like what is the thing made?
No, there is no specific name. It's just platinum and iridium alloy.
Okay, platinum.
Okay. So it's platinum and iridium alloy kept at International Bureau of Standards, Weights and Measures, Paris, France. Copies of it were generated and those copies have been distributed worldwide.
Hmm.
Okay. So those that we take as a 1 kilogram. Now the mass does not, the mass can change over time. Mass can also change over time if there is radioactivity or any other thing, then mass can change. But this alloy, it shows least radioactivity and it is kept at a standard. It is kept at a standard temperature and pressure so that there is no change. It is closed in a container. Okay. Then how we define 1 second? We have to define a moment of 1 second. So how we define 1 second? See, in the similar way, just we define length, we define mass. So the same way, your time is also defined. And for time, we use an atomic clock. That atomic clock we'll call as the cesium clock. It's made up of cesium-133 atom. Okay. So what happens to cesium-133 atom? In cesium-133 atom, we count the number of vibrations. Okay, so that is the best clock that we use, and we count over there the number of vibrations. Okay, so whatever is the number of vibrations, see, we define that as the number of vibrations per second. How many? There is a number of vibrations. Let's see, 1 second. So you have defining of 1 second. You have some number of vibrations which are counted over counted over between two hyperfine levels of cesium. See, 1 second is the amount of time it takes for 9192631770 cycles of radiation to pass between two levels of cesium-133 atom. Okay, so basically, as of now, I don't think that you understand it in anymore. You will be finding it very difficult to understand, but you do not remember. You should not remember these words. Yeah, you are not supposed to remember these numbers and all. Yes, you should understand that how we are reaching at a standard, why we are choosing a standard, and what this standard means. So 1 second, it actually means to 9192631770 transitions of cesium-133 atom. If these many cycles of radiations, that means if the cesium-133 atom radiates this much of radiations, so you count these radiations, if the number of radiations is 9192631770, then that interval of time will be called as 1 second. Okay, so I hope you have understood this definition of 1 second. So this is the most appropriate clock which is being used. Got it? So cesium, this is the definition of 1 second. So we can define 1 second as the number of transitions of 919276 and 458. I think that's the number. Yeah, 9192631770 cycles of radiation of cesium-133 atom. So if this many radiations we are going to count from cesium, we call it as 1 second. So in the similar way, all the standards have been kept. you cannot use any substandard. For example, you cannot make a meter stick and say that this is 1 meter. You cannot choose an iron object and say that this is 1 kilogram. There is a standardization to everything. In the similar way, we have defined temperature, Kelvin. So what we call as 1 Kelvin. Okay. So for defining 1 Kelvin, we have something as triple point of water. Beta, see, I expect all of you to keep your cameras on. This helps me in keeping on giving out a proper classes. Okay. You can use any backdrop if you prefer. So, are you getting these things or not? Are you able to get all the things?
Yes, sir.
Yes.
Yeah.
Okay. So all the things should be understood. If you are not able to get any points, do inform. The best way is that we communicate. If you do not know, do not get, these are the basic points, basic definitions of a system of units. So see how we define 1 Kelvin. 1 Kelvin is defined as the 1 over 273.16 of the triple point of water. So, what do you mean by triple point of water? One Kelvin is defined as 1 over 273.16 of the triple point of water. So, let's see what is triple point of water. By triple point of water, as you know, that we can change from water to ice to water. So, at what temperature does this transition take place from ice to water? Yes, at what temperature does ice change from ice to water?
Sir, above 0.
Above 0.
Yes.
So, okay, let's say above 0. I'm writing here above 0. Okay. At what temperature does water change to ice?
100 degrees Celsius.
Water to ice
At 0.
at 0. Right? You say
Yes.
at 0?
Yes.
See, this is not the condition. The condition is actually here. You do not have only temperature as the function. You have here two other things which are playing role. You have here two things. You have here temperature, and apart from temperature, you have atmospheric pressure. So pressure is another factor which affects melting and freezing. Right? So 0 degree Celsius is the equilibrium position. At 0 degree Celsius, it can exist at ice, as ice also, it can exist at water also. So a combination of temperature and pressure, a condition of temperature and pressure at which water will exist in all the three forms. Right? So there will be a condition of temperature and pressure. For example, the pressure given over there at time is 0.01 bar. Okay. So at this pressure and a temperature, so that water will exist in all the three forms. So that is a single temperature. So 1 over 273.16 of triple point of water. Triple point means the temperature at which water will coexist in all the three forms. So you can very well guess that what is the level of standardization. Okay, we have standardized everything so that there is not even a minor chances of the units being disrupted. Okay, so 1 Kelvin is 1 over 273.16 of triple point of water. So in the similar way, we have defined all the other fundamental quantities. all the other fundamental quantities like we see here length, mass, time, temperature. In the same way, amount of substance is mole. So in the same way, it has also been defined. Current has also been defined as 1 ampere. So in similar way, so what current we will call as 1 ampere of current. What amount of light will be there, so that we will call that light to be 1 candela. So these all are SI system of units, and here we see that all the units, everything, they are standardized. All the units have been made into a standard, right? So these was today's class. We had discussed about the fundamental units or fundamental physical quantities. They are also called as basic physical quantities. Funda means basic. Now, all the other physical quantities, they can be written in terms of these fundamental quantities. Okay. Any other physical quantity. For example, if we try to write down volume. Okay. So suppose we write down volume over here. We find out area. We find out volume. So volume is generally written as L times B times H. So length, breadth and height. So breadth is also a type of length. Height is also a type of length. So all these can be measured in dimensions of length. Right? So volume will have the dimensions of L cube, length multiply length multiply length. In the similar way, area can be expressed in terms of length only. Area means length multiply breadth, whereas breadth is also a type of length. Okay, so we will call these quantities which can be made by using other fundamental quantities. These physical quantities, they are called as derived units. So the quantities which have been made from, which can be obtained by other physical quantities, they are called as derived physical quantities. The quantities which cannot be defined in any other terms, they are the fundamental quantities. So these are derived physical quantities.
Definition again.
For derived physical quantities,
Yeah.
the quantities which can be expressed in terms of fundamental quantities. Okay, anyone who has not understood anything? See, we will start from the very basic, raise the standards slowly as we go deeper into the chapter. Okay. So what are the anyone having any doubt?
No.
No?
No, sir.
See, your doubts will be cleared here only. And I want everyone to be speaking, to be active during the class. It's not a passive class. You have to be active during the class. Okay. Suppose if there is a class of 1,000 students, then you can be passive. But here you have to be active. And here I'm writing the definition for the derived physical quantities, the quantity which can be expressed. Quantity which can be expressed in terms of fundamental quantities. Okay. So the quantity which can be expressed in terms of fundamental quantities are called derived quantities. So can anyone give me any other example of derived quantity? Yes, anyone can give any other?
Speed.
Speed, very good. Speed is a derived physical quantity. Any other? What about force? Is force a derived physical quantity or not?
Yes.
Yes, force is a derived physical quantity, right? So now you have got the definition. What are fundamental quantities? What are derived physical quantities? Just one more thing adding up here. Here we have discussed mainly about the SI system of units. So SI system of units, they are the international system of units which have been accepted for measuring the physical quantities. However, some people may use other units like FPS system. You have a CGS system. So can you guess what does FPS system stands for?
Foot, pound, and second.
Yeah, foot, pound, and second. So it will be FPS means foot, pound, second. CGS means centimeter, gram, and second. You have MKS system, meter, kilogram, second. Okay. So these are the different system of measurements. But here, throughout our studies, we will be referring through SI system of units. Okay. So bye everyone. Just if you had any doubts, so please do inform me right now. Jaswant,
Yes, sir.
uh, did you understood everything?
Yes, sir.
Okay, see. So today we just started with the basic of the units, how we measure the physical quantities, right? Okay, bye everyone. Good night and see you tomorrow again at the same time.